chapter 10. Now, we just got through doing the Pythagorean theorem, and I must say, I'm very impressed with you. Most of you did quite well. So now, we're going to simplify the square root of 160. In other words, we need to find two numbers we can multiply together to get 160, and one of those numbers can be perfectly square. Mr. Cruz, what two numbers come to your mind that could be perfectly, one could be perfectly square, and one probably going to stay up under the radical?
16 and 10.
16 times 10, the square root of 16 times the square root of 10, right? So let's work it. The square root of 16 times the square root of 10. That's what that means. Now, if I'm looking at the square root of 16, Mr. Cruz, close the door, baby. If I'm looking at the square root of 16 times the square root of 10, what is the square root of 16, Cruz? Okay. Can I perfectly square the square root of 10?
No.
So therefore, that stays up under the radical. Question. Any question? No question? Okay, let's look at, yes, Mr. Brandon.
If so, 4 and square root of 10 is equal to 160.
No. The square root of 16 times the square root of 10 equals to 160. We have simplified this by saying that a perfect square, now this 4 times the square root of 10 would equal to 160. Okay? Because we done simplified it as far as it can go. Good question. Any more questions? Are you copying this down for your own future reference? Okay. Now we're going to look at number 4 on the board. Number 4. I'm going to put it on the board. Again, right here in front of you. No, I'm not going to write it anymore. Go over there, Mr. Ellis, and roll that over here. Because I've already went over with the rest of the class. Previous classes. Okay, just roll it right on over here. Put it right there in front of everybody. Thank you, Mr. Ellis. Turn it on around. Let's look at this problem right here. Now, this is in your book. If you look at page 623, number 4. The problem is the square root of 15x over x raised to the third power. That means 15x divided by x to the third power. Anytime that you are looking at this exponent, which is 3, and right here there's an exponent 1. We didn't put it there because we know it's understood. You're going to subtract. When you're dividing, you're going to subtract the exponents. When you multiply with the exponents, you're going to do what? Add them. So in this case, we have x to the first in the numerator. We have 3 in the denominator. So x minus 3 gave me a negative 2. A negative 2. So x raised to the negative second power. So now we have 15 x raised to the negative second power divided by x. The square root of 15x to the negative second power divided by x. Now, concept. I want you to remember this as long as you do math. Anytime you have a variable or a number raised to the negative power, you're going to write it like this. Give you some examples. I have 2 raised to the negative second power. That means 1 over 2 to the second, simplified, which is 1 over 4. Okay. Anytime you have a variable, which let's say x to the negative 5th power. X to the negative 5th power, we read x, 1 over x to the 5th power. Okay. Now talk to me. What do you see that is constant with this one and with this one right here? What is constant, which will never change? No. We have a 1 in the numerator. Anytime you have a number or a variable raised to a negative exponent, you will always have that 1 in the numerator, and then you're going to kick the expression down in the denominator without the negative sign. Okay? Question? Okay. Mr. Gardner? Question? Did I answer your question? Okay. That's concepts. Remember. Now let's go back to our problem. We have x here and a negative x to the negative second power. I rewrote it because I got to see something. I got to visualize. So I rewrote this so I could understand it. The square root of 15 times the square root of x to the negative second is rewritten to the square root of 1 over x to the second. I had to rewrite it so I could visualize it. Divided by the square root of x to the first. Now let's simplify. 15 times that 1, the square root of 15 times the square root of 1 gave me square root of 15. Then I have x to the first power here and an x to the second power. I am subtracting 2 minus 1. 2 minus 1, which gave me an x in the denominator. So the answer is the square root of 15 over x. I need some questions out there in the neighborhood. Talk to me. Talk to me. No question? Am I doing that well? Okay. Now, I broke it down to the bone right here, which is just rewriting this over here. Okay? No questions. Now, let's look at problem number 3 in your book. I know you got all of that, so we're going to just go ahead and erase it off. Now, Ms. Williams, I want you to call out problem number 3 because I'm not looking at it. I know it's 3. 3 times what? The square root of something, right? The square root of 5. M times 4. 1 over 5. M to the what? To the third power. Okay, now that's our problem, but we got to break it down. We got to put combined like terms. If they look like a duck and they quack like a duck, it's going to be a duck. We have whole numbers here. What whole numbers do you see there, Miss Sylvia? The outside the radical. What whole numbers do you see? So we're going to multiply 3 times 4. Okay. Then I got me a radical. I have a 5 and I have a 1/5. So let's make that 5 look like a fraction. How can I make that 5 look like a fraction?
5 over 1.
5 over 1. Thank you, Mr. Ellis. Square root of 5 over 1 times the square root of m times 1, the square root of 1/5 times the square root of m to the third. See, I wrote everything out because we finna put it together. Okay? Now, looking at these terms right here, what do I need to put together there, Mr. Cruz? You on fire today. Okay, I know I can go ahead and simplify that. 3 times 4. 12. Okay. What do I need to put together now?
The m with the m to the third.
Well, what about the square root of 5 over 1 times the square root of 1 over 5, then the square root of m times the square root of m to the third. We're going to put those all together. Question. What is the square root of 5 over 1 times the square root of 1 over 5? What's 5 times 1?
5.
What's 1 times 5?
5. 1.
Well, somebody said a 1 out there. That'll work for me. Okay, now let's simplify these. Now, when we said we're going to multiply exponents, what what do we do with those exponents? Do we subtract them or add them? Wrong. What you say, Johnson? Add them. So I got a 1 here. Let's put it so you can see it. I got a square root of m to the first power. I got a square root of m to the third power. So 1 plus 3? 4. So now we have the square root of m to the 4th power. Everything is being simplified. Now the square root of 5 over 5 equals what? 1. So I got 12 times 1. And now we're talking about the square root of something. What's this exponent?
4.
What's the square root of 4?
4.
What's the square root of 4?
2.
2. So therefore, that's m to the 2nd power, which is equal to 12 m to the 2nd. I broke it down like this so you can see every step. Now, really, truly, I didn't have to do that, but I wanted you to see how we process it through. I need you to ask me some questions. No question? Now you tell me that you understand everything I just did. Wow, appreciate you. Y'all got this?
I know.
Okay, now if you don't have it, that means your hand should have went up in the air to ask questions. Brandon, talk to me.
Like, how you get this 2nd power on the m right here at the bottom? Go down.
Because you see that 4, this is a radical. I know it doesn't look like 1.
I get it. I
That's
see
the
now.
square root of 4. Gave you that 2. So the square root of 4 gave you 2. We added the square root of m times the square root of m to the 3rd.
And our full answer is 12 m to the 2nd power.
That's it, baby. That's it. Okay? Any further questions? Can you handle this? Come on, Taylor.
When you had to make the 1/5 look like a fraction.
Okay, talking about 5 over 1.
Why you had to put this to the 1 over 5 again?
No, this 1 over 5 came here. See, that's the original. That's the original problem. 1/5, the radical 1/5 came right here. So because we had the square root of 5 right here, I want to work with fractions because, like I said, I'm a visual person. I want everything to look alike. So that's why I put 5 over 1, because I had 1 over 5, which is a fraction. And I knew I was going to combine these two together. It's a good question, baby. Good question. Okay, good question. Okay, are there any other questions? Any other questions? All right. If there are no other questions, we're going to let it stand right there. Now, you do have homework. It's on the board. Page 623, 2 through 32, even only. Page 623, 2 through 32, even only. Okay? No questions? I'm letting it stand. I'm down. I'm out. Out of here.